what happens if you have another category or characteristic that you want to stratify your sample based upon? And that's what we'll look at in this example. And by the way, this is just like your worksheet. So you would want to use this as an example if you get stuck on your worksheet. So our population this time, we're using this data, the number of students by major, level, and gender, and find stratified sample numbers for each category. Use a sample size of 45. So I can see on the next page I'm going to use that, so I just write that in 45 down below. First thing, the two important characteristics. Now you are going to have to list this out based on the scenario that you're given for your worksheet, so don't forget to do this. There's two to do there. And one characteristic that we're going to look at for our example here is gender. So is the person male or female? And then another thing we're going to look at, a second characteristic of the population that we're interested in, is the college of their major. So we have all these categories: College of Business, College of Ed, College of Liberal Arts and Sciences, College of Fine Arts, non-degree, undeclared is one category. What we want to do to start with is write down the percent of the population that has each of these characteristics. And so we're going to need to go back to our data sheet, and this one we want to do students by major. So this is the one we will look at. So you're going to look at this sheet again, and we're looking at first the College of Business, how many males, how many females. So we're not considering undergraduate and graduate separately, so we will have to tally again. So we'll want to add up this number plus this number to give us the males in the College of Business. And if you just mark a diagonal on every box, that's going to help you, because we have to do a couple of things on here. We're going to find the total number first, and then we're going to calculate what percentage that is out of all our students. So I just went ahead and marked through each of my boxes so I have space for two things. I'm going to make my pen a little bit smaller and come back to the students by major sheet. So I wanted to add the 216. So the 216 plus the 76 males that are graduate students, and I get a total of 292. Come back here. So that will give me 292 College of Business males. Come back to our data sheet. Now we want the females for the College of Business. So now we're looking at 219 plus the 78 . We get 297. And then I'm going to go ahead and add those two and just check myself. 297 plus 292, and I get 589. And I'll come back to this sheet and double check. I do have 589 students, so that's really helpful. And so now what I'm thinking about here is I want to know the percent, like what percent out of all my students are College of Business males. So I sort of need to think about the total, and we have 55 students, so I'm going to write that down here, 55 all together, and that's 100%. So coming back to the College of Business males, I have 292 out of 55. So 292 out of 55. If it comes back up, there we go. that gives me 0.0498, and there's a 7 after, so it's going to be 4.99%. And now I can do that the same thing for the females, so 297 divided by 5855, and I get 5.07. The next digit's 2, so I'm just going to leave it 5.07%. Make sure you put your percent signs on there. That's very important. It's going to help us distinguish between what's percents and what's just numbers. And then the last thing I want to do is find the 589 out of my 5855. So 589 out of 5855. And I get 10.05, but there's a 9 following, so 10.06%. Now I want to add those up and make sure that I'm really close. So 4.99 plus 5.07 equals 10.06. So those are adding up so far. That's good. So I'll follow this same process for College of Ed, for College of Liberal Arts, for College of Fine Arts, and for non-degree / undeclared students. The very last thing that I want to do is double check my totals. Okay, so I've written in all the numbers for the students from the College of Ed, and remember that comes from this page. If we're looking for College of Ed students, for males, I will take this 269 plus the 137, and for females, I'll take the 2 female numbers, undergraduate and graduate. Same thing, College of Liberal Arts and Sciences, and you have to kind of watch the orders slightly different on the sheet. So I have 635, and I'll add the 48, and then the 973, and I'll be adding the 296. That'll give me the females for the Liberal Arts and Sciences. That's where I came up with all of my numbers, and I had already totaled the male and females, so I used those again on my page. And you can see here where those numbers are the same, 2324 and the 3531. And I wrote down those percents since I'd already calculated them. Now remember, I can come to this 406, and I want to know what percent the 406 is out of my 5855. So always out of this total, because all of these together should add up to 100%. So 406 divided by 5855, and for that I'm getting 6.93%. And then you continue on figuring out the percent. So the next one will be 870 divided by 5855, the next one 1276 divided by 5855, and so on. So what I want to show you now is how you do some cross-checking on your table to make sure that your values are correct. And this is really important to do because when we collect data, we have lots of information, and we want to make sure that our table is internally consistent. So within the table itself, we want to do as much as we can to make sure we haven't just written down the wrong number. So we do a lot of checking back and forth to make sure we accomplish that. Now, the first thing I would want to do is add up the 292, the 406, the 683, 180, and 763. So I have 292, 406, 683, 180, 763. And I get 2324, and that's perfect because that's the number of male students that I had at Eastern from my previous look at the data. So I'm going to add up all the females now, 290. And when I add those, I get 3531. That's good. That's the number of males I expected to have. Now, I do these totals two ways. I add up these numbers, 292 and 297, and make sure I get 589. And then I add up these percents, the 4.99 and the 5.07, and I make sure that I get the 10.06, but I also take the 589 divided by the 58.55, 589 divided by 58.55, and I get 10.06, as you can see there. So I know that this percentage is correct, but I also verify that these two add up to that percent. And then the next thing, once I've got all of those inside of my table where I feel like they're accurate, then I double check these percents, like add up all of these. So I have 4.99 plus 6.93 plus 11.67 plus 3.07 plus 13.03 equals, and I get 39.69, and that matches the percent that I have right here. That's perfect. Now I want to look at the percents for my female students. So I have 5.07 plus 14.86 plus 21.67 plus 3.57 plus 15.13, and I get 60.3, and that's where I'm off just a hair from this one. So when I actually add up all of these percents together, I'm going to be one off. So let's see if I can show you what I mean. So if I add up these two percentages, I know it comes to 100. I've already done that. But when I add up these percentages, I'm a little bit off. So let's see. 10.06 plus 21.79 plus 33.34 plus 6.64 plus 28.16. And I get 99.99. So I know I'm off, and that is due to rounding, and it's not a huge problem. I could go back through each of these totals and double check their percentages against the out of 58.55. Okay, so the percent should total 100, and I kind of showed you what I was doing to find those percentages. And let's move on here. So using those percentages, so I found the percent for each category. What I want to do now is find for my sample size of 45, how many people do I need to speak to that will be male College of Business students? How many female College of Business students? How many male College of Ed, female College of Ed, and so on. And that's what I'm trying to find now. Since I know what my percentages are, I'm just going to write them into my table. But first, I want to make those lines again, because that's very helpful to keep track. I need 2 bits of information here to finish this table. And there we go. The total number on this table, because my sample size is 45, that's what I'm expecting to have for the total down here. So this should be 45 and 100%. So now I'm just going to write in those percentages I came up with from my last table, just so that I have them on this table as well. And so it was 4.99%, 5.07, 10.06,